So we've already talked about the discriminant. We call it the discriminant b squared minus 4ac, and I just finished talking about why it's specifically b squared minus 4ac from the quadratic formula. And we talked about this a few days ago. Remember that there are three possible outcomes when solving a quadratic equation. If we think about how a parabola crosses the x-axis, and we talked about how solving a quadratic equation that's equal to 0 is the same as finding x-intercepts. And this is something that I think a lot of people don't take enough time to really think about that and what exactly that means and what that looks like and how that's true. So I would encourage you to do that. That being said, you take my word for it. And if you look back at what we just did with the sketching where we were finding x-intercepts, it was the same thing, right? So you can see it. It's not that complex. But here are the three different types of solutions that we can have. So this one has how many x-intercepts? 2, thank you. So 2 x-intercepts, which means it has 2 different real roots. We're talking about this thing called, I should have probably opened with this, but the nature of the roots, what does that mean? Roots is another way of sort of saying x-intercepts or solutions, okay? So it really just means the same thing for us. It does have a slightly different meaning in the greater subject of mathematics, but for us, we can kind of use it interchangeably for solutions or x-intercepts. I am going to briefly talk about a little bit more about that, but not yet. So 2 different real roots or 2 solutions, all kind of different ways of saying the same thing. And what this looks like is b squared minus 4ac will be greater than 0. And we've talked about that, but we're rewriting that and redoing it kind of thing. And there's a little bit extra to this one. The other 2 are shorter, but this one's there's a little bit more to it. If b squared minus 4ac is a perfect square, then what? Well, what is a perfect square? Or what are the perfect squares? Shout them out. What's the first one? 1. Thank you. Keep going. Good. Keep going, Mackenzie. Good. Keep going. 36. That's good. ... Keeps going. We know. I mean, it goes on forever, so we can't list them all. It would take us a long time. Then what? Then you can factor. If b squared minus 4ac is a perfect square, one of those values or one of the big ones, then you can and should factor. Otherwise, quadratic formula. So if it's not a perfect square, and all you have to do is when you type it into your calculator, you don't have to know the list of perfect squares. When you type it into your calculator, I'm trying to think of a good example. Okay, I would go that didn't work. 7 squared minus 4 times 12. Okay, that gave us 1. That's kind of an easy one. That's not a very good example, but we'll use it anyway. You just take the square root of that answer, and if you get a whole number, then it works. So, for example, if you got 289 and you don't know what that is, you just say square root, and oh, it's 17. Whereas the square root of 288 gives me a decimal. So that's how you can tell without knowing the list. Plug it into your calculator, and then just hit your square root button. Okay, and that'll tell you if you get a whole number. That'll tell you if it is factorable, if it's a perfect square. That's one of the options. The next one could look like this. Whoop, let me try that again. How many x-intercepts do we have here? 1 x-intercept. Now, and I hope we understand that this parabola has an equation. That would be like y equals something. But if instead of the y, I thought of it as an equation equal to 0 that I can solve, that's what we're talking about. I could think of it as y equals, or I could think of it as 0 equals. And I'm going to show you an example of that in a second. So if it's y equals, it has 1 x-intercept. If it's 0 equals or equal to 0, we say this. This is a weird way of saying it, I know, but just go with me. We have 2 equal roots, or 2 solutions, or sorry, 1 solution. 2 equal roots, but 1 solution. And this is something we haven't talked about, I don't think. Maybe we did briefly, but b squared minus 4ac will equal 0. That's how we know 2 equal roots, which is 1 solution. b squared minus 4ac would equal 0. And again, if you think about the quadratic formula, if b squared minus 4ac is 0, the plus or minus doesn't matter, because that's the thing you're adding and subtracting, so you only end up with 1 solution. Okay, so an example of this is if I had x squared minus 6x plus 9 equal to 0. So if I factor this, this is something that you would be able to factor. And if I factor it, I would get x minus 3 times x minus 3. I get the same thing twice. So from this bracket, I get x minus 3 is 0, and x equals 3. And x minus 3 equals 0, and x equals 3. So I get like 2 solutions, but they're the same. It's 1 solution, but we do call that 2 roots. So we say it's 2 equal roots. And notice that this is if I'm solving, if it's y equals x squared minus 6x plus 9, that would be the equation of the parabola that we saw in the little sketch. This is the equation of a parabola. This is an equation that I can solve. Everybody okay with that? We all good? The last example, does anybody know what the last one is? How many x-intercepts we can have? Brooke? None, very nice. So I could have a parabola that goes like this. And I think we can all agree, visualize, even though we can't see the whole graph because the arrows tell us that it goes on forever, I can tell this quadratic, this parabola will never cross the x-intercept, the x-axis, and have no x-intercepts because both of the sides of it are pointing off up, and the whole thing of it is above the x-axis. So this one has, we say, no real roots and no solutions. Why do you think we say no real roots as opposed to just no roots? Anybody have any idea? We're going to talk about something that's like a really important thing in mathematics, but not for us in this course. But it's like hugely important in the bigger world of mathematics, and I think it's really interesting, so we're just going to talk about it briefly. Why do you think it says no real roots? Yes? Good, I like that answer. Okay, you're on the right track for sure. 0 does have a square root. It's 0. What about the square root of negative 1, for example, though? Because you can't take square roots of negatives. Does anybody? Very good. Right. So mathematicians are weird people, and they're like, you can't take a square root of a negative number because no number times itself gives you a negative. And I should look this up because I'm not sure who it is, but somebody's like, what if you could? What if you could take the square root of a negative number? And they're like, okay, I'm going to call that I. So they called the square root, just randomly made that up. And then all of a sudden, this whole other side of mathematics was created. And it turns out that even though we call them imaginary numbers, they actually exist. And there's this thing called the fundamental theory of algebra. I know this is starting to get really technical, but don't worry, go with me on it. It's really, really interesting. The fundamental theorem of algebra says that every quadratic equation has 2 solutions. It has to. This has been proven. But we are saying it has no solutions. But that's because the number system that we work in, we only work with these things we call real numbers. There are other numbers. And those are where the solutions are. And there's really awesome videos all over YouTube that you could watch that actually prove this like really nicely. Like you can kind of tell, even though you don't have to understand any math. It's just visual, and you're like, oh wow, look at that. Yeah, I see it. And so there's this whole other thing. So anyway, we're not going to get into that at all. But if you explored other kinds of mathematics, took other math courses, took math in college, university, you might start talking about this thing called I. And a lot of people think it's really unfortunate that we call it I and we call it imaginary, because they're not imaginary at all. But somebody did imagine them and ask what if. But like, it's a huge part of mathematics, and it is very interesting. And the last thing I wanted to say about it was, it's very much like when you were first introduced to negative numbers and they made no sense, and you're like, negative numbers don't make any sense. Like you can't have negative 2 apples. You either have apples or you don't. Like that's what, right? And that's how human society worked. That they only had positive numbers because they only counted things that they had or they didn't have. But now you've been working with negative numbers for long enough that you're like, negative numbers make sense. I understand them. You can plot them on a graph, and we understand that maybe it's like debt or like negative degrees outside or something like that. Right? So we kind of understand them now, and imaginary numbers are very much the same. It seems wonky that you would have real numbers and non-real numbers. What? But if you work with them a little bit, it would actually starts to make sense. Anyway, what were you going to ask?
I was going to ask what course like.
So in the grade 11 university level course here, they talk about I a little bit, but they really just start doing the skills to work with it. They don't really get into the details of it, but they start to explore just a tad little bit of it. And sometimes in advanced functions we talk about it, but we don't always. But then if you took it in like university, you would start to explore it. Yeah. Sarah, did you have your hand up too at one point? No? Okay. Thought I saw that in my peripheral. So getting back to the stuff that we actually need to know. What does that mean for us? What will the discriminant be if it has no real roots? It'll be negative, and that means less than 0, or you can think of it as negative. Very good. So we've kind of got these 3 situations. Positive, bigger than 0, 0, or negative, less than 0. And if it's positive, we can use the discriminant to tell, should I factor or not? Right? So it's useful for that as well. But those are kind of the 3 situations. So let's explore all 3. We're going to do a couple of things here. Determine the nature of the roots of each equation. That sounds important, doesn't it? The fundamental theorem of algebra. It's like just fun to kind of say. It makes you sound like you know what you're talking about, even if you don't.
Would you study like this kind of thing? Like, what would data management be based on?
Data management has a lot to do with probability and statistics, which is a totally different branch of mathematics. But a hugely important one to the real world, because like companies and stuff hire statisticians and people like that all the time. And then also probability, so that's things like making reasonable choices based on the numbers or that kind of thing as well, right? So that's that. I does not come up in data management. There's also a fundamental theorem of calculus. There's probably fundamental theorems of all kinds of things, but anyway. Determine the nature of the roots of each equation. So what we're going to do when we have to solve a question like this is just b squared minus 4ac. And normally I said you didn't have to write this down. You didn't have to show any work. I'm going to show extra work today just because that's kind of part of what we do. Hello?
Sorry, can you see Brooke real quick?
Absolutely. Well, it's fine with me. I don't know. How do you feel about it, Brooke? It's an awkward question. Okay. So I'm going to show some extra work to give you a sense of exactly how the math works, but you know there's not a lot of hard math involved here, so we can just kind of cut to the chase. But anyway, A is 2, B is -1. Some of you on the learning goal today noticed that if you got the sign of one of these things wrong, it didn't work out. We're going to talk about that. And C is 3. Right, and that just comes from, again, if you want to watch, if you want a quick review, there's your A value, the coefficient of x squared. There's your B, the coefficient of x. And there's your, oh, it's not 3. Sorry, I was looking in the wrong place. It should be 6, shouldn't it? Plus 6, because that's my C value. My mistake. You must have thought I was losing my mind there when I wrote 3. Okay, so 2, -1, and 6 are my values. So we plug those in, and I've got to put the -1 in brackets, because the b squared part will always be positive. I've said this before. I know I'm repeating myself, but it's a good reminder. Always be positive. If you punch it into your calculator and it turns out negative, you've done something wrong. -4 times 2 times 6, which is 1 minus, what does that work out to? 24? -23. Therefore, we make our conclusion. We don't solve anything in any of these. It didn't say to solve any of them. It just says determine the nature of the roots. So therefore, somebody help me out here. Yeah, no solutions or no real roots is what we're going to say. No real roots. But that also means no solution. No real roots is what I want you to say today. When we're talking about roots, we say no real roots. Oh, thank you. Yes. Oh, okay. So this should be 48. Yeah, see, I did it again. It's because I changed the question and I'm looking at my notes. -40 instead of looking at the screen. Thank you. Still no real roots, right? Still negative. Okay, good. Next question. What's different about the first two questions? That's the only difference between these two. One little sign. A is still 2. B is still -1. And C this time is -6. Do you think that's going to change anything? Before you solve it, I want you to just look up at the screen up here. Because the 6 is negative, when I multiply two negatives, what do I get? A positive. So now this is 1 plus 48. So like when I'm looking at this stuff and when I'm solving these questions, everything I'm looking at is those signs. Making sure I don't miss them, because that's going to make all the difference in the world. Is it going to end up being plus or minus in this case? And in this case, I get 49. Whereas in the other case, I got -47. You folks are so distracted about something, I can tell. So whatever's going on is, whatever's going down right now is big. Okay, so, does that make sense? So what do I conclude here? Help me out. Why only one? It's a perfect square. That's not what only one means. Let's go back up. Only one is when it's 0. So it's positive bigger than 0, so there's going to be 2 different real roots, 2 solutions. But the fact that it's a perfect square, we're going to get to that in a minute. So let's do this first. Therefore, there are 2 different real roots, which means 2 solutions if you're actually solving it. And what else? Because it's a perfect square, we know we could, if we had to solve this, we could factor. So we can factor if we want, but as long as the question doesn't tell you, if you choose to use quadratic formula in those cases, it's a lot slower, but you could. You wouldn't have to factor. Quadratic formula will always work. Okay, we got a couple more here. Yes? So the fundamental theorem of algebra says that all polynomial equations, which is what these are solvable. And if it's a degree 2, it'll have 2 solutions. If it's degree 3, it'll have 3. If it's degree 4, it'll have 4. But that's only if you have those imaginary numbers. So we don't work with imaginary numbers. So for us, sometimes they're not solvable. That's right. But in the greater world of mathematics, these kinds all are solvable. But in this class, they're not. And they're not solvable when you get a negative under the square root, right? When there's no real roots, not solvable by us. Does that make sense? I know that's kind of like a mathy answer, but that's the full true answer. Okay, so let's do this one. Anybody notice anything about this one? Are you happy with this? Is everybody happy with that? Noor? So be careful because it's got nothing to do with the order that the terms are written in. And it has, it's a busy place here today. It has everything to do with the coefficient of what it's in front of. So the x squared term is always your a, and the b term always your b. And the constant, the one that doesn't have an x, is always your c. Okay, so b squared minus 4ac is 2 squared minus 4 times negative 4 times 4. So that is a negative and a negative is positive. So this is 4 plus 64, which is 68. So what can we conclude?
There are 2 different real roots.
Very good. 2 different real roots. And if you had to solve it, how would you solve it? It looks like, why would it be a simple trinomial? Yeah, but is it factorable? 68's not a perfect square, so not factorable. So we would have to use the quadratic formula. And again, you don't have to know the list of the perfect squares. You do it on your calculator after you've entered it, is what I would do. Everybody okay with that? Yes?
When you rewrote it, is it okay, like how you switched the numbers, negative 4 and 2, is it okay to just do it without them?
Yeah, if you're doing a question like this, where you're just doing the nature of the roots, as long as you did it correctly, you wouldn't have to rewrite it. In some cases, it's a good idea to rewrite it. Oh, and by the way, this means 2 solutions, right? But you don't have to state that every time I'm stating it, but 2 different real roots, which means because they're different, you have 2 solutions. Okay, this is our last example. It's going to actually be our second last. I'm going to add one more. But Oops. What's 4 times 4 times 9? Somebody do just that part on their calculator? 144? And 12 squared is 144. 4 times 4 times 9 is 144. So what do we get? 0. Therefore, we say 2 equal roots. But that means there's only one solution, and I'm actually going to show you this one. If we were to factor this, you would get 2x minus 3 times 2x minus 3, which equals 0. So it's also factorable. If you get 0, it's going to be factorable because 0 is a perfect square. So it's always factorable. And it's always going to be factored this way with two brackets that are the same. We call that a perfect square trinomial. You could write it like this. And it only has one solution. Because they would both be the same. If I did both brackets, you'd get 3 over 2 twice. And the last thing I just want to talk about, I don't know if you have to write this down. I guess you can try if you want. So this would be E. If I did something like this, x squared minus 9 equals 0. What's my B value? No, not quite. This is like x squared plus 0x minus 9. So A is 1, B is 0, C is negative 9. So if I wanted to do B squared minus 4AC, I still could. But I'll give you a little hint here. You'd never really have to. So this would be 0 squared minus 4 times 1 times negative 9, which is positive 36. So that's factorable, and we know that's factorable. It's a difference of squares. I hope we know that's factorable, and it certainly has two real solutions. Or if I had something like this, x squared plus 6x equals 0. So A is 1, B is 6. What's my 6? What's my C value? It's 0. So you could do the same thing, and I'll leave that with you if you want to try it. But it's the same. The 0 is going to make part of your thing disappear, and it's going to, you could still use the discriminant, but if we understand what we're doing, we don't really have to, because those kinds will both of those kinds will always work anyway.